Continuing with section 2.1c, we now look at some examples which are a little bit complicated because they are a combination of the functions that we learned how to find domain. So in this case, for example, number 7, so we have a radical function on the top, and which is an even root because it says fourth root. And then at the bottom we have a polynomial. So the bottom we cannot have it 0, so we have to take care of that. And then in the radical sign we cannot have negative numbers. So we use the techniques that we have learned before. So we will, for the one thing we have to do is look at the radical function. So from there what we do, we take the radicand or the expression inside the square root, the fourth root, and or inside the radical, and we set it greater than or equal to 0. Now because it's in the numerator, so 0 is allowed. Okay, so we can say greater than or equal to 0, which will give us x is greater than or equal to negative 9. Okay, so we hold it there, and now we go to the bottom. 2x square plus x minus 1. We set it equal to 0, or as I showed you earlier, not equal to 0 if you want, and we now solve it. So it's better to solve it with factoring. If you don't know factoring, please learn. A quadratic formula will also work, but it takes more time. So the factors will be 2x. So it will, one of them will be 2x something, and then there will be x something. So we will have 1 here. Now we have to decide what will be the sign. So the sign in here will be positive and in here will be negative. So this is equal to 0. So which gives me that x is equal to 1/2 or x is equal to -1. So we cannot have these two in the domain. Okay. So now when we are going to look at the domain, we basically have to look at all three things. What three things? Well, one is this, and other is this and this. That x cannot be 1/2, x cannot be -1. So the domain will be, so if we only had the denominator, the domain would have been -infinity to 1/2, -1/2, and -infinity to -1 comes first. Yeah, so see, it's always good to draw it. So this is -2 or -1. Then we have 1/2 somewhere here, and then there is also the number -9. So where will that be? It will be to the left here somewhere. So we are not going to start from -infinity now. We will be starting at -9 because x must be greater than or equal to -9. So the domain will be equal to -9, comma, -1, parentheses, union, -1, comma, 1/2, union, 1/2, comma, infinity. That will be the domain. Okay, going to the right side in number 8. So here we have square root. So it means we have to take the quantity inside the square root, and we have to set it greater than or equal to 0. But what is this? This is a quadratic inequality, which you learned in 1.8 or we reviewed in 1.8. So what I do is factor. So I get x minus 4 times x plus 2 greater than or equal to 0. Okay. Now remember, you cannot say, so this will be wrong. Wrong method if you say x minus 4 is greater than or equal to 0 or x plus 2 is greater than or equal to 0. Okay, and why is it wrong? Because from here you are saying x is greater than or equal to 4 or x is greater than or equal to negative 2. So you are saying that a value which is, for example, negative 5. Okay, so x is greater than or equal to negative 2 is saying everything is greater than negative 2, and this is saying x is greater than 4. So this is kind of comes in here. This is included in this one. But if you take x is equal to negative 5 and plug it in this expression, so what do you get? So this will give you that g of negative 5 equal to, so negative 5 whole squared minus 2 times negative 5 minus 8. And you simplify this, it gives you 25 plus 10 minus 8, which is equal to 27. And 27 is a number which is greater than 0. So it means the function could take the value or input as negative 5. So, which means our domain is not correct. So where is the mistake then? The mistake is when you write something like this, you are treating it as an equation. This is not an equation. So we do not solve the quadratic inequality like quadratic equation. We have our method is the way we solve it is using the sign chart. So now because we have the equality, now even if you don't have the equality sign, what you have to do is you have to find the zeros. So what are the zeros here? 4 and negative 2. Okay. So we'll put them on a line. So negative 2 and 4. And now we pick test points which you can keep in your head or you can put them like on top here. Negative 3, 0, 5. So now we plug these in the function. So I can plug them in here or I can plug them in this expression, or you can go and plug them over here. So you will see that when we plug in negative 3, this will give me, because this is x minus 4, so negative 3 negative 4 is negative 7, and negative 3 plus 2 is negative 1. So both of these factors are giving me negative. So negative times negative is positive. So we have a positive sign here. And then if I plug in 0, so you can clearly see we are going to get a negative sign. So it's negative here. Now when you plug in 5, we already saw that gave us a positive value. So which means now the domain is, so remember what we are trying to look for is where is this expression greater than 0. So that is between negative, to the left of negative 2 and to the right of 4. So the domain will be, I'm going to write the domain here. Domain negative infinity to negative 2 union 4 to infinity. So if you are getting a quadratic function inside the square root, you have to use sign chart. Okay, now looking at the next example. Again, this is a combination of functions. So it's there is a numerator and there is a denominator. So and both have are radical functions, square root functions. So for the square root, for the numerator, we will take the quantity and say that this has to be greater than or equal to 0. So 5 minus x has to be greater than or equal to 0. Okay. So from here I'll go that 5 is greater than or equal to x, or x is less than or equal to 5. Okay. Now we leave it there. So this is something that we will come back. So in the denominator I have 9 minus x squared. It has to be greater than 0. Why not? I'm saying not equal to, because it's in the denominator. If I set it equal to, greater than or equal to 0, it means I'm allowing 0 to be in the denominator, which is not correct. So, but now look at this. This is a quadratic inequality. So you are not going to solve it like a quadratic equation. You have to factor it. So 3 minus x and 3 plus x is greater than 0. Okay. And now we make the sign chart. First the zeros. Zeros are 3, negative 3 and 3. And then we make the sign chart. Now pick a number, negative 4, 0, 4. So when I plug in negative 4, so the first factor will give me a positive sign, and the second factor will give me a negative sign. So I will have a negative sign over here. When I plug in 0, then I will get a positive sign. Okay, and then when I plug in 4, I again get a negative. So I had to have it greater than 0. So from here you can now draw the domains. So for this one, my function values should stay between negative 3 and 3 with parentheses here, because negative 3 and 3 are not included because we don't have the equal to sign in here. But now we look at this expression. So this is saying all real numbers, so less than or equal to 5. So which means 5 is somewhere here. So everything less than or equal to 5. So yeah. So we can say everything over here. And from the previous one, we were saying only this portion. So which means now we have to look at where the two domains or these domains of these two functions overlap, which you can see is only this portion. Therefore, the domain of the function is negative 3 to 3. Okay, last part. So again, notice here, this is 3 over 9 minus x square root. So in the first term, the first expression, we have a number on the numerator, so we don't have to worry about that. But at the bottom, we have a radical expression, and then which is a square root. So it means we have to set the radicand greater than 0 and solve that inequality, which is the same thing that we did here. Can anyone notice that the domain of this function will be the same as the domain in the problem part 9. So this is 9 minus x square is greater than 0, and x plus 5 is greater than or equal to 0. So if you notice, these are exactly the same condition that we had there. So which means I don't need to do it over. So domain is in this case also -3 to 3. So this is how we find the domain.